Dear all, welcome to this new episode of the CATIA TV, this time focusing on the concept of reverse engineering. In CATIA, and by using 3D experience, reverse engineering can become a very powerful design tool, and our subject matter expert, Dominique Coz, will present you the latest innovations in this cutting-edge domain. Historically, as computer-aided design, CAD, has become more popular, reverse engineering has become a viable method to create a 3D virtual model of an existing physical part for use in 3D CAD, CAM, CAE, or other softwares. The reverse engineering process involves measuring an object and then reconstructing it as a 3D model. The physical object can be measured using 3D scanning technologies like CMMs, laser scanners, structural light digitizers, or industrial CT scanning. As usual, the CATIA TV will be presented here in this post, so don't hesitate to interact with us and don't hesitate to ask your question. We wish you a very good webinar.
Hello, everybody. My name is Patrick Pochat.
And my name is Dominique Coz.
So we will present today the topic 3D digitalization of assets. Dominique and myself both belong to Daniel Pisac's team, and we are in charge of all the supports that we can provide regarding everything that is related to reverse engineering. For this presentation, we've been working with Amin Hamami, who did most of the presentations. So thank you to him. And let's see the presentation now. First, so you have to know that more and more our customers not only want to do reverse engineering on their products, which means on the objects which they design and produce, but also on their assets, which means on their factories, on their buildings, on their shop floors, and so on. Why do they want to do that? Well, it's simply because they want to have a digital twin of their installations, so that they can organize a lot of things. For example, navigate through the building, document the building by adding annotations or creating links to documentation, or to prepare any kind of maintenance or refurbishing operations, which can be prepared virtually on screen before they start being actually executed in the building. Or also, a very important thing is the control. So they can control that their virtual twin and their original design in CAD match, or maybe detect defects. That's all the kind of things which you can do in reverse engineering on plans and assets. What's the problem with that? The problem is that you have to create a 3D digitalization of your of the site, of the factory or workshop or anything, and usually you will get a very, very large number of points, much more than what you get when you're just digitalizing a part or even an object or a car or something like this. So that's the first problem, very large number of points. And the second one is that you also need some specific tools which were not necessary before when we were just doing reverse engineering on products. So what do we have in 3D experience for that? Well, we have these four values, which are that we have, of course, a lot of modeling tools for reverse engineering, which have been developed over the last years, which are very efficient and very mature. And we have now in 3D experience a possibility to import very large clouds of points, which were not possible to be imported before, or not even mentioning V5, which is not able to import large clouds of points. So we have also started developing dedicated tools for the management of plans. And we also benefit from the integration of CATIA and Delmia, because Delmia also proposes a lot of dedicated tools for everything that is related to the manufacturing process, including the management of workshops, for example. Okay, so examples. We have some examples here of large clouds. So you see on the top right, in the top right window, an example of a workshop. It's a welding workshop in a factory in France. You see the possibility to navigate, and you see that this is a cloud of points, but if the definition is sufficient, you have the possibility to be exactly as if you were walking inside the building. If you look at the bottom left image, you see that with a sufficient resolution, you almost think that it's a picture. You can read the signs, for example, you can really detect all details. Of course, if you look at the oil platform, you see that you have the possibility to have a very complex assembly of shapes. The factory is 1.3 billion points, the oil platform 5 billions. So very, very large number of points. You cannot import that directly into the reverse engineering applications. But what we have to do that is a possibility to import a large cloud. So with a technically, it's a component of 3DEXPERIENCE which has been developed by the Delmia development, and that is included into the reverse engineering product. So you have the possibility to import a very large cloud containing billions of points. And if you want to do some reverse engineering, the possibility to extract a small, or not so small, but extract an area by a box, for example, which is one of the possibilities, but there are others. And then once you extract a part of your cloud, you have the possibility to use it as a reverse engineering cloud. That means with the digitized shape to shape preparation application, digitized shape preparation, or digitized shape to surface. Okay, so that's the idea. If you have a very large cloud of points, you have to extract the area in which you want to work, and then you'll be able to do some reverse engineering. And that means do what we will see in the following steps of the presentation. Okay, so let's see that in on a real case. I also want to thank the Faro company because they have provided us with this the cloud of points which we will be using in the videos. So first we will see how we can easily navigate inside the building that has been digitalized in 3D.
So, as Patrick mentioned, in this example, we imported a cloud of points, 73 millions of points, courtesy of Faro. You can see how easy it is and how fluid it is to navigate inside the cloud of points. Again, 73 millions of points. As a matter of fact, last week I imported 4.3 billion points and navigate inside the same way. So some functionalities you can do very standard inside this navigation is the capability to add some 3D annotations, potentially to identify equipment. Why not? And so you will set these 3D tags, and it will ease the possibility to read what is inside and understand what you are doing. Another possibility could be to slice, make a section of your cloud of point to better see some inside area, for example. Or what you can also do is use the measuring tool, the standard measuring tool from CATIA, and compute some distances. Here, the goal may be to check the feasibility to import a new equipment inside and things like that. I mean, there's a lot of different scenarios that you can do with that. As you see, very simple, very fluid, and easy to use.
Okay, so that's what you can do on a large cloud of points. That's the first step of reverse engineering. It means you do not create anything, but you navigate. The second step is interesting. It's it will show the capacity of merging a cloud of points with an existing CAD model, an existing virtual model of the installation, so that, for example, you can compare what has been designed to what really exists, which is very important. One of the applications of that is, for example, to follow the evolution of a construction by digitalizing the construction site from time to time in order to see what's evolving.
So, for example, here in this example, you see we will focus on some piece of equipment. The first function is to isolate the piece of equipment to work with it easier. As you see, very simple. We make a small extract, and from this small extract, all the tools from reverse engineering standard capabilities are available, such as here in this case, the capability to recognize cylinders, spheres, reconstruct complex surfaces, and so on. And after that, of course, you have a CATIA part that you can manipulate, and like here in this case, again, to do some maintenance scenario, for example.
Okay, speaking of inserting standard element or standard components, that's what we will see now in this next video.
So very often in plants, technical pipes are often painted in specific colors to identify their function. So like here, we use the functionality to be able to extract by color cloud of point, and it helps us focus on what job we want to do. The first step is to recall from a library standard parts, because of course they are manufactured parts, so we don't want to rebuild them. And then we will position it inside the cloud of points. Again, you use the power of the 3D experience and the power of CATIA in order to adjust things to the digitized world. Another possibility is to be able to recognize the pipes as cylinders, for example, here. As you see, the cylinders are editable very flexibly, very user-friendly, and you can even constrain them. Like here, we want to have a normal pipe, for example. The goal is to be able to rebuild the pipes integrated inside the cloud of point, as you see here. So here we managed to create very easily the given pipe integrated inside your plant digital twin.
Okay. Next is important. It's really a question of dedicated tools which are necessary in the context of plant digitalization, because they are okay. That's a question of productivity. It's the possibility to recreate planes.
Yes, so you can decide, as Patrick mentioned, to recreate the planar surfaces inside your plant, for example, in this context. And we have a function that will allow you to investigate the whole cloud of points, 73 million of points, as I remind you, and segmentation by color of all the planes as a preview in order to focus on what you want to work on. And then you get a recreation of planes as a standard CATIA entities that you can manipulate. Moreover, after that, we are just keeping inside the cloud of point what remains to be done. So we are deactivating all the points that were consumed to create the planes. More to come. We will work on a functionality in order to recreate all the cylinders the same way. So we will add this capability very soon. And later on, we also work on a possibility to recognize procedural surfaces. What do I mean by procedural? I mean all the extrusion and all the sweep surfaces. So this way, you will be able to recreate your twin factory much easier.
Okay. Next is an example of the integration of all these capacities in CATIA. For example, in that case, you will benefit from the capacities to create kinematics to move an element inside the cloud of points.
So there are many scenarios for assets management. One of them, as Patrick mentioned, consists on checking the accessibility of equipment. For example, here by a forklift. A forklift we recall, of course, from the library, and to be able to check for the possibility to move around the plant and to move equipment in and out of the plant. So this is done very simply using standard CATIA features. But as Patrick mentioned at the beginning, you can also complete the work by using a Delmia application because the data is recognized for all applications inside the 3D platform.
Okay, so that was a general presentation of what you can do with the 3D digitalization of factories and plants and so on. What is important to remember is that we have the capacity to read very large data sets, so billions of points, 4 billions, 5 billions of points. That's okay. And you can navigate inside these 4 or 5 billion of points easily and in quite a fluent way. Then you have the possibility to extract a subset of these billions of points, so that you will be able to recreate actual CATIA geometry, planes, cylinders, and so on, or be able to do whatever you want to do inside the 3D experience with all the possibilities of the 3D experience. So of course, all the traditional reverse engineering tools are still available. All the tools which existed already in V5 and have been enhanced in the 3D experience are available. And you have dedicated tools for that you wouldn't really need for classic reverse engineering on mechanical parts, for example, but that are necessary to manage clouds of points in that context. And of course, remember the integration with Delmia, which gives the possibility to do more in the area of plant management. Okay, so that's all for this presentation. Thank you for listening. And do not hesitate to contact us if you need any support on your reverse engineering projects in general, or more specifically on your reverse engineering projects in the area of plant design. Have a good day, everybody.
And looking forward to hear from you on your reverse engineering projects. Thank you for attending this virtual event. The 21st century is highly virtualized, as you may have noticed. One of the promises of the 3D Experience platform is to allow you to manage the assets of your industry. This includes digitized data from various different sources that you will be able to handle inside the 3D Experience platform. CATIA proposes several tools to manage data coming from digitization world. As you see in this slide, you will be able to use output of high-density scanners to perform your job in all the different departments of your industry. To name a few, as input for inspection, for manufacturing directory on STL files, for classic surface reconstruction, but also using the output of FEA simulation to perform your part, either to compensate the deformation coming from the manufacturing process, spring back for stamping, for example, or warpage and shrinkage for plastic injection molding. Or also, you may want to update your part to reflect the real physical part after manufacturing. So you see a lot of different types of context for reverse engineering. 3D Experience Reverse Engineering offer will allow you to use dedicated tools that will take into account the fact that the data is issued from scanners, accuracy, size of the data, quality of the scan, and reconciliation of the data to the CAD model. It will also allow the user to manipulate and process huge amount of data. For example, last week I imported a 4.3 billion point scan data, and work with it. And this in a very productive way, thanks to the 3D experience infrastructure. The user will be able to integrate scanned data inside the standard CATIA process using dedicated efficient tools and benefit of the best of both worlds, scan and CAD data, this seamlessly. The user will also benefit of a unique tool to morph a CAD part, keeping the integrity of the part, internal continuities, topology, and so on, to take into account the deformation coming from the manufacturing process. And don't forget, it is a unique portal to address all your needs using Cloud of Points or STL data, whatever the source, smartphone, tablets, industrial camera, scanners, and whatever the process you want to address inside the 3D experience platform. So, in short, a complete set of applications allowing you to import, heal, complete, process digitized data, and also to create geometry based on the digit data, curves, surfaces, in conjunction with analysis tool, and so on. Let's see in action what I meant in the previous slide through 6 different scenarios. In the first example, the goal is to reconstruct a trim steel tool. The customer doesn't have the CAD data, so the tool was tuned manually long time ago. Nevertheless, we need to have a digital twin to recreate the tool in case this tool breaks. And as you know, this happens. For example, you scan the tool, you import in CATIA the STL file. Here, we will recreate a solid box exceeding the part size, and we will enrich the box little by little, like here, creating, for example, sections on the mesh, approximating later on this section into segment and arcs and ellipses. The result is a fully constrained sketch that you can edit and complete manually, like here, extrude it with standard extrusion functions, and refine the box you previously created. Let's create another section to complete the design. Approximate it in segment and arcs, and enrich the previous box. Now for the pocket, it's a little different. We will use a combination of sectioning plus canonic surface recognition. What I mean by canonic is planes, cylinders, spheres, cone, tori. In this case, we want to find the plane of the bottom of the pocket. We will merge these two entities together and trim the design with this pocket, very simply. Now, to recreate the active cutting surface of the trim steel tool, as this is an organic surface, we will automatically create a NURBS surface to a given accuracy, and this on the selected area of the digitization, as you see here. And then we will integrate this surface inside the previous design. So here, the work is almost done. We will complete the work by standard filleting operation to complete the tool. Here you go. So customer is now safe and ready to manufacture a replacement cutting tool. In this next example, I will need to recreate free-form surfaces from a car body. This tool will allow you to create Class B or Class C surfaces. First, we will use a kind of a surface curvature analysis on the STL. This will help us locate the boundaries of the surfaces to recreate. So you can see the tool is very easy to use. It will lay down curves on top of the STL file to a given accuracy. Very simply, as you see here, some kind of constant fillets, which are not exactly fillets, they are styled curves. And maybe sometimes it's not constant fillet. So here we will do a variable fillet, for example, on 3 points, giving different radii for the filleting. Then remains to connect all these pieces together. So we have simple tool to connect, as you see, simple click connection of the fillets. And now you may want to tune these connection files, for example, in order to better adjust to the fillet shape. So once the curves are created, here we are finishing the curves with the virtual edge of a fillet, for example. Once the curves are created, you have a network of curves that are laying on top of your STL file. And the goal is now to use a dedicated tool to recreate surfaces based on this network of curves, laying on top of the STL to a given accuracy, and the resulting surface network can be constrained to be tangent. Now let's check the quality of the produced part. We want to compare it to the CAD data. So we want to compare it at two levels, accuracy in millimeters and potentially with respect to the FTA tolerances you have set on your CAD model. Like here, for example, you have a solid model in CATIA where the user put some FTA tolerances. So first import the STL file inside CATIA by a simple drag and drop. Then first we will check the deviation analysis to compare the differences in millimeters. So here you see both parts, STL and solid, and we want to compare the distance between both of them. In order to better analyze the differences, we will create a colored map of the distances, fully customizable. As you see, even going around the part, you will see the different distances. But you can also attach 3D tags onto this deviation analysis in order to focus more on specific defect area, for example. So here, simple distance analysis. But as you see in the dialog box, you can also tell the system to flag these annotation, red and green, depending on the accuracy the user sets. So now at the second level, we will control the compliance to the FTA that was set on the CATIA solid model. So you want to control that the manufactured part is respecting the FTA. Very simply, same way with a red and green tag, the FTA will be tagged OK or KO status. All right, so now we have done a few reports. We want to export this data to be able to share it maybe with a subcontractor, for example. So there is a functionality that allows you to create a report in HTML format, and it will be very easy after that to export it, exchange it to a subcontractor. So for example, here is the HTML, and inside the HTML, you will find all the information that was captured inside CATIA, like here, deviation analysis, FTA, and potentially also different pictures that snapshots that you have set inside CATIA. The next step is you checked in the last video that there was some mistakes, some differences that are too big. So the goal here is to compensate the CAD model to anticipate the manufacturing deformation in order to ensure that the produced part is compliant to the required accuracy. So origin and part orientation are usually not kept during the scanning process. So CATIA proposes several approaches to register your digit. So like you see here, you have the solid model and the STL file that was not at the proper location. If your part contains planes, cylinders, spheres, area, there is a simple tool inside reverse engineering that will allow you to first detect these planes and cylinders, and second, adjust your STL file to the location of these spheres and cylinders. So for example, here we set coherency with between two cylinders, and we will enrich this connection to two planes. As you see now, it's almost done. We have another translation to be done by using two other plane connection. So this is good when you have some mechanical parts like planes and cylinders. Now, if you have a more organic part, then we also have a best fit command that will allow you to tune the STL file to some dedicated surfaces automatically. So adjust, minimizing the distance. One-click operation. Now, let's compare the CAD to the physical part using deviation analysis. So that's the same tool we saw earlier. We compare the deviation between both STL and CAD data, but it is only a deviation. It's not a deformation. So we have a tool also to transform the deviation into a deformation. From that, you will be able to morph your CAD part by taking into account this deviation that was computed. So here, just representing the deformation. But if you edit it, you will be able to compensate going on the other direction of the deformation. So applying the deformation with a minus sign. So you are anticipating the deformation. For example, this is exactly what we are doing here on the spring back effect on a stamping of a car door. We used a CAE application to compute what would be the spring back effect on this stamping process. This is what you see. And what we do, we are compensating the spring back going to the other direction. As you see, same topology, same quality of the surfaces. Very easy process. Now, what about the other way around? What do I mean by other way around? From virtual to real 3D printing. You are able to prepare your 3D printing operation, taking some STL file, for example, and giving some thickness to it, even on complex area like here, we have the outside of the bottle and we want to create the inside. Or take a complex assembly like here, this car model. And what we want to do is to take all these solids from the assembly, that's in the CATIA assembly, as you see here. And from this complex assembly, generate STL file in one click, like here. So create an STL file by taking some constraints like caudal deviation and maximal size of the facets. And of course, after that, you can export on disk your results. Lately, there is a growth for refurbishing. So here, this is a cloud of 73 million points. You will see that the 3D Experience platform will allow you to import a huge cloud of points to be able to work with them and have a digital twin of your factory, for example, usually for maintenance and refurbishing. Like here with this example from courtesy of Faro, in the 3D Experience platform, here you will be able to have all these points. By the way, last week I worked on a 4.3 billion points in the same way. Here we attach some 3D tags, for example, to isolate some entities, or you may want to compute distance between elements, maybe, for example, to check feasibility, to import a part inside, remove equipment, and so on. Or start some reconstruction process like here, recognition of planes and cylinders, approximation of surfaces, like we saw earlier. And then you'll compare the existing CAD with the existing 3D model. So deviation analysis again, same tool as we saw, working here on 73 million points and some solids or surfaces, for example. See by color the deviation from the original. Now, very often in plants, technical pipes are painted with different colors to identify their use. As the scanner was capturing the color, you may also extract point by color like we did here. You will be able to recall standard parts from library, like here with the valve, and to position it, because no need to recreate a valve. But you can also recognize pipes like here by just selecting a point on the cloud. System will analyze and find the pipes like you are doing here, integrating the pipe inside your virtual model. Another scenario is a maintenance scenario in order to check feasibility mounting and dismounting equipment like you see here. And the latest tool that we are providing is the possibility to generate automatically all the planes. For example, here on the 73 million points, we automatically detect all the planes, segment them by color to a given accuracy. And here you see the result of the generation of planes inside your model. And more to come in the near future. You will get automatic recognitions of cylinders to complete with the pipes, not manually anymore, but automatically this way. So this was some of the scenario on where to use reverse engineering inside a 3D experience platform. There are many other possibilities, as this role is an important brick of all industry segments. Thank you for your attention.